Good morning everyone. It's me Chandakla here. In last class we were looking for units of length and we have done up to light year. Now we will start parsec. So first of all we have to remember the fact that parsec is also a unit of length. As we see the name, it looks like a unit of time, but it's not time, but it is the unit of length. So here two things are there. One, definition is written here, and the definition says that actually the distance from where semi-major axis of earth that is 1 astronomical unit sustains an angle of 1 second, or you can say 1 arc second, whatever you want to say, you can say. This is one definition. So the concept starts from the fact that as we know that our earth is not exactly spherical, it is somewhat elliptical. So that means we know that our both these axes are not equal. So we are saying that the semi-major axis of earth, when it sustains, suppose any star is there, when it sustains an angle of 1 second, okay, for example you are looking from here, or if you are looking from here, and this angle is of 1 arc second, this is actually, that means you can say this is 1 astronomical unit and this is known as 1 parsec, or you can say simply parsec. This is the meaning of definition. Now what is this? See, in earlier classes, that means in our geometry classes in mathematics, when we learned to draw a line segment, then our teacher told us one concept, that when you are drawing a line segment, suppose you have to draw a line segment of 8 centimeter, then obviously you will take your meter scale and you will put your scale here and you will put its 0 mark. This is point A. Here you are having 0 mark of your scale and you have to draw a line segment of 8 centimeter. So up to 8. Suppose this is 8 centimeter. So this is point B. That means this is a line segment whose length is 8 centimeter. Okay, it's very easy. But one more thing at that time told, and that was that while you are drawing this line segment, when you have kept your scale at this 0 mark, then your eye should be just above the 0 mark. Okay, that means in this line here, just above this A, your eye should be there. If you are putting scale aside like this and from side you are drawing 8 centimeter segment, line segment, and that means putting your eye at different angles from this line. If you will draw 8 centimeter segments, 2-3 segments, then if you will carefully observe again their measurement, then you will get a difference in them. That means not very much difference, it will be a very minor difference. That means you can say 0.001 or 0.005 or 0.05, something like that, but still they will have a difference. That means if you are not putting your eyes exactly on the scale, then your measurement will become inaccurate. And what is this? This is known as parallax. And same, this parsec actually has been came out from this parallax only. If you are looking a same object from two different places, then you will get them at different places. That means actually at one time you will see that the star is here, another time you will see that the star is here. However, difference between these both positions will not be much, but still it will be there. Okay, so that means obviously it depends on our position, observer's position, our eyes position accordingly. So if we are, and this 1 arc second, this is nothing actually, the same concept which you have learned in mathematics. We have learned angles, and in angles we have learned degrees. That means 30 degrees, 45 degrees, 60 degrees, and after that degree, if we want a smaller than degree, that means any value less than 1 degree, then we goes for minute. You might have heard some examples, for example 30 degree and 5 minutes, which is represented like this. Similarly, if we will go for further smaller unit, then it will be second. So that means actually this second is nothing but it is a measurement of an angle, but this is very small measurement, that's all. Okay, so that means 1 parsec is the distance from this point to this. That means when our semi-major axis of 1 astronomical unit sustains an angle of 1 arc second, this is known as, then the distance is known as 1 parsec. Okay, for here, for this we are having a formula, that is 1 parsec into 1 second is equal to 1 astronomical unit. Same things which we have used here, we have written here. You see, this is 1 astronomical unit, this is 1 second, the angle is 1 second, this is 1 parsec. Okay, so from here we can say that 1 parsec is equal to 1 astronomical unit upon 1 second. Now value of 1 astronomical unit we have already learned, that is 1.496 into 10 raised to power 11. This we will see. And here for 1 second, if you want to write down, you can write down numerical values. 1.496 into 10 raised to power 11, this is in meter. Now if we want angle, then first we have to convert our degree into radian, which you have learned in your maths, and then we are having a minute, and then still smaller, that is second. So likewise we will get the value of 1 parsec. So therefore 1 parsec is equal to 3.08 into 10 raised to power 16 meter. As I said, at least we will have to remember its relation with meter. However, one more relation is given in our book, that is in the form of light year, which is equal to 3.26 light year. But if you cannot learn this, at least learn up to here. I said it's important, at least we should know relation with respect to meter. So it's needed here. And some more smaller units are given here, which are smaller units but actually non-metric. For that, 1 angstrom is equal to 10 raised to power minus 10 meter. This we have learnt in chemistry when we learnt size of atom. And 1 Fermi is equal to 10 raised to power minus 15 meter. This we have learnt when we learnt the size of nucleus. Okay, here 1 nanometer is also given. However, we have already seen the nanometer and it is a metric unit actually, but still it's given here because sometimes we may need to relate this angstrom and nanometer. So these are some extra units. Okay, now we will go for our next topic. Till now we have covered only one topic, that is length. Now we will go for mass. So we will learn for unit of mass. As we always do, our first work will be the SI unit, and SI unit of mass is kilogram. This we have already seen. Okay, so then the next thing is, what is the definition of 1 kilogram? What do you mean by 1 kilogram? That we have to define. So as we have seen for the length, with respect to same things we will see the definition for mass. In length we said that one platinum iridium rod is kept in the International Bureau and 2 markings are there on that rod, and the distance between both markings is known as 1 meter length. So similarly here 1 kilogram is defined as one same, we will say, platinum iridium cylinder is kept, iridium cylinder is kept where? In the same International Bureau, and the weight of this platinum iridium cylinder is said to be 1 kilogram. Rest of the things you can add if you want, that is 0 degrees Celsius and all that. But here the definition, it is same as we have learned in the length, but there we were learning about length, so we said a distance between 2 marking. Here we are learning about mass. So the mass of that platinum iridium cylinder, which is kept at International Bureau Paris, is of 1 kilogram. So again we will consider it as a standard, and then we can make some weights with this measurement for 1 kilogram, for 5 kilograms, for anything 2 kilograms. Then they will be the standard weights and we will be using them in our daily life. So for mass we have only one definition right now, and that we have to learn this one. 1 kilogram of mass is said to be the mass of a platinum iridium cylinder kept at International Bureau Paris. This is the definition. Now we have to see some subunits of mass. Subunits of mass. Here we have taken kilogram as SI unit. So the first one will be gram. Okay, and no need to explain much, because we already know relation, that is 1 kilogram is equal to 1000 grams, or in other words we can say 1 gram is equal to 10 raised to power minus 3 kilogram. This relation we already know. Second is milligram. As we have already learned the prefix, milli means 10 raised to power minus 3. Therefore, we will say, here we are talking about gram, so we have kept gram. So, milli means 10 raised to power minus 3 gram. After that, some multiple units are given. Multiple means some larger units. Some multiple units are given, in which the first one is quintal, which we already know actually is equal to 100 kilograms, and the second one given is metric ton. This also we know, that is equal to 1000 kilogram. Okay, then some non-metric units we have to see. Non-metric means which will not depend directly on kilogram. Non-metric units we have to see. So only one non-metric unit is given, that is AMU, which is nowadays also known as, simply denoted by U, that is AMU or U. This is nothing. Same atomic mass unit which we use in the chemistry. Same atomic mass unit which we are using in the mole concept, that is that one AMU is this one. So we will derive the value from definition itself, which we have already learned, that 1 AMU is equal to 1/12. 1/12 means 1/12 of carbon 12 atom. So we want atomic mass of carbon, that is 12, because we are saying carbon 12 atom, because we know that carbon will have some isotopes also. We are talking about carbon 12, and here obviously we will need Avogadro's number, and that is also with respect to kilogram. That means generally we learn in chemistry for gram. I already told you there we use smaller units, somewhat smaller units, but here we are working for kilogram, so we are writing 10 raised to power 26, whose value comes to be 1 AMU is equal to 1.66 into 10 raised to power minus 27 kilogram. Actually our work will be this one only. We just want this numerical value, because here SI unit is kilogram, so we want its relation with kilogram. Okay, so either we can directly remember it from here, or we can derive it, or we can calculate it from here. These are the units of mass. Rest of the things we will see next class. Thank you.